the 5th video in a series of videos that go over a Desmos activity called Make Them Balance. The name of the Desmos activity is right here, Make Them Balance, and Ina Chile is the individual working on this Desmos activity currently, and that's me. So this screen asks us if the ordered pair is this ordered pair 2, 7 a solution to the system of equations. So essentially, when you have two equations written like this, and you have two equations, you have this one at the top, top one, bottom one, and you have two unknowns. You have two variables, x and y, that you do not know. When you have a setup like this, two equations, two unknowns, right, two equations, 1, 2, and two unknowns, x I don't know, y I don't know. They are variables, they are unknowns. This is called a system of equations. Ordered pairs, 3, 9, can be solutions to the system of equations. And what it means to be a solution to the system of equation means that this value, if I plug in x for 3 for x, and if I plug in y, 9 for y, into these two equations, they will both simultaneously equal the same thing. Sorry, they will both simultaneously be equal. So let's see what I mean here. Let's try that. If I plug in 3 for x to the top equation, 2 times 3 is 6, plus 3 has to equal, y is equal to 9, so I should have written 9 here. 9. 6 plus 3, 9 equals 9. That equals, which is great. Now let's try doing the same thing to the second equation. 2 times 3 plus 9 has to equal 15. 2 times 3 is 6, plus 9 is equal to 15. 6 plus 9 is 15. That's equal to 15. Both equations simultaneously equal when I plug in 3 for x and 9 for y. This is equation 1. This is equation 2. This is equation 1 and 2. So a solution to a system of equations is an ordered pair, x, y, that makes the equations equal, that makes both equations equal. So we need to know, does this point 2, 7 also make both equations equal? So I'm going to erase, and I am going to click on the hanger and see what happens. So this is telling us that 3, 9 is a solution to the system of equation. Is 2, 7 also a solution to the system of equations? On the graph, only one point made both hangers balance. 3, 9. Only 1 point. So there can only be one solution to the system of equations. Only one solution makes both equations equal. Only one solution makes both hangers balance at the same time. So this point 2, 7 cannot be a solution to the system of equations. 2, 7, when we graph 2, 7, it was on the red line, so it made hanger A balance, but not hanger B. All right. If let's try plugging in 2, 7 into the equations and see if they equal. If I plug in 2, 7 into the top equation, I get 2 times 2 plus 3 is equal to 7. I'm going to write it like this. 2 times 2 is 4 plus 3 is equal to 7. 7 is equal to 7. So this one is equal. Let's try the second one. 2 times 2 plus 7 is equal to 15. 2 times 2 is 4 plus 7 is equal to 15. 4 plus 7 is 11. It's equal to 15. No, this is not true. 11 does not equal 15, so the point 2, 7 cannot be a solution to the second equation. Therefore, it cannot be a solution to the system of equations. So we're going to click no. Explain your thinking. We can say the point 2, 7 balances